If you're a DBA, you know the feeling. It's the weekend, maybe it's after hours in the middle of the week, and you're about to patch a SQL Server Availability Group manually. You know there's multiple steps in doing that correctly, especially if you want to keep downtime to a minimum. And there's always a sense of dread. What if you change a setting and you forget to change it back? Maybe you're changing the failover mode so that you don't have to worry about failovers happening. Maybe you're changing from async to synchronous. There's a lot of different things that you can change as part of that update process. And that's what I want to talk to you about today in this video. Over the past few videos and blog posts, I've showed examples of how to do this with Ansible, but I'm taking it a little bit further. I've actually created a new role that's part of my automatesql.msql Ansible collection out on galaxy.ansible.com, and I'll put a link to it down below. But this is a collection of tools that I'm building up to show not only examples but also to use for managing SQL Server on Windows with Ansible. Ansible is not a replacement for PowerShell or some of the other tools that you may have used like DBA tools. It's more of an orchestration tool that uses PowerShell in the background. Now, Ansible does have a lot of built-in modules to where you can use it standalone, especially when managing Windows, but not a lot of built-in modules specifically for SQL Server on Windows. If you're completely new to Ansible, you can grab this guide here out on automatesql.com. I'll put a link to it down below. But what that's going to do is it's going to send you a PDF that you can use to kind of take your first steps as a SQL Server DBA with Ansible. And then it's also going to send you a guide over variable precedence in Ansible, because with Ansible there's a lot of different places you can use variables, and knowing if you have multiple variables set, which one's going to take precedence will save you a lot of heartache and when you get ready to run your own playbooks. The first thing I'm going to walk through is kind of the manual checklist, a typical manual checklist for doing applying a patch to a SQL Server Availability Group. In some cases, you may want to patch all of your secondaries, wait a week or two, and then come back and patch that primary after you've made sure that there's no issues. The role that we're going to talk about today has that capability to where you can not patch the primary. We're going to patch it today, but just know that if that's something that you typically do, then this role will work. The DBA's weekend patching checklist, this is going to be for a 4-node SQL Server AG, kind of the manual process or some of the steps that I would do that I would do as part of that maintenance window. So phase 1, you've kind of got your prerequisites or your pre-patching sanity checks. That's going to be verify full backups. That's not something that this role specifically does, but let me know if you think that would be helpful if it could do that. So always verify your full backups. Doesn't matter if you're on an AG or if you're on a standalone SQL Server instance, maybe a failover clustered instance. Always make sure that you've got backups, and those backups you can restore from those backups. So make sure you're doing your restore tests. Check the AG health. You can do that with the AG dashboard. You can also do that by running queries against several different views and tables in master to get those replica states. You always want to make sure it's synchronized and it's healthy, because you don't want to go and make modifications to an unhealthy AG. So if it's unhealthy, stop and figure out why first. Document the current state. So you want to go ahead and make sure that you've got each server name documented. Like if you're doing it manually, then you know exactly which servers you're going to be hitting. In our case, all of our servers are going to be defined in an inventory file for Ansible. You also want to document that version. So if you do need to roll back, once you roll back, you want to make sure you're back at that version of where you started with. After you've done that, you confirmed everything. Phase 2, you'll move into patching your secondary replicas. A lot of steps here that you're going to have to go through typically for each one of those nodes. Connect to the primary and you want to go ahead and set manual failover for that secondary. So take it from the failover mode of automatic, if it's set that way, to manual, just so that the AG cannot failover to that instance while it's while it's being patched. Verify the setting, verify that it's changed. You can do that with the dashboard, or you can do that with another query. Connect to the secondary, so RDP into the secondary, copy your patch there, or if you've got access to it over a network. I always like to run those patches locally, the executable locally, just so that if there's a hiccup in the network or anything like that, then it's not going to impact my installation. Install the patch, run the executable, and then install that patch for those specific instances that you intend to update. Go ahead and restart the server. Once you've restarted, verify that SQL Server service is running and the AG is reconnected. Verify the new version, so you want to make sure that new version matches your patch level that you intended to be at, and then reset that failover mode back from manual back to automatic if it was set that way previously. And then make sure that you can do this with a query or the dashboard as well. You can make sure that it's healthy and synchronized, and then move on to your next secondary. So in the case of the role that I'm going to show you, by default, Ansible will do everything in parallel. So it's going to patch every one of the secondaries at the same time. If you don't want that behavior to occur, then look up the serial. You can add the serial option into your playbook and set that to 1, so that it's just going to patch each secondary individually, do all the verifications, and then move on to the next secondary. So you'll notice that the primary is done at the very end, but you do have the option of not doing the primary at all. Back to the manual SQL Server patching checklist. So phase 3, you're going to fail over the primary. So step 1 is to choose the target. Choose one of your secondaries that you just patched, is in a healthy state and is synchronized, and then fail over to that replica. And once you've done the failover, make sure that the AG is still in a healthy state, and then move into phase 4, where you're patching that former primary. So you're going to connect to that primary, set manual mode. So these are the same steps that you did above in phase 2 for your other secondaries. Basically, this is just a going back through those same steps, but now you're patching the former primary. Phase 5, optional failback. So if for some reason you always want to be running on that specific instance as the primary, maybe you're not synchronizing jobs or logins or anything, and you always want to be back on that primary, then you'll need to go and fail back. So during a failback, you know that all of the connections to that database are going to cease, at least until they reconnect after the failback. So just know that is a downtime event. And phase 6, you're going to do your post patching validation. So you're going to verify that the version is set to what you expected it to be for all of your replicas. You're going to verify that the state of the AG, it's healthy and synchronized, and then reach out to any of your application owners so that they can start testing to make sure everything looks good, and then close your maintenance window as long as everything was good. So that's kind of that's the manual checklist. A lot of different steps, a lot of places to where if you make a change you may forget. I know I've done it in the past, leaving a replica set to manual failover instead of setting it back to automatic, or maybe your AG is now running on a different primary than where it started. So this role is designed to put the AG back in a state of where it was before, so idempotency, but the only change that's staying is, of course, the build level. So Real quick, this is the role out in Ansible Galaxy. This is the README for it, SQL AG patch. You can see I have another one here called SQL install. That's one that I use for the Ansible for SQL Server DBAs course, but it's a role that can be used to install and automate over 60 different steps as part of that installation. So we, as DBAs, we know that we don't typically just stop after the installation. We don't just next, and we're finished with SQL Server. There's a lot of other steps that we need to go through to configure that instance the way we want it. And that role is designed to show how you can use Ansible to automate all of those steps. And if you're building out a new environment, let's say you're building out a new production environment that has to have 5 instances, 6 instances, whatever, you can use that SQL install role to install SQL Server and configure it, and all of those will be configured the same way so that you know it's done correctly. It may not even be you. You may be a senior DBA and you want to offload that to a junior DBA, but you want to make sure that those installations and configurations happen as if you did it yourself. Then that's a good way you could do that by using Ansible. Ansible kind of brings these checklists to life. It basically automates each one of those steps and orchestrates those steps and validates along the way that it's consistent with your intention. So this is the roles, the role variables, and we've got a set of required variables that we will touch on real quick, and a couple of these optional variables. So the AG name, you got to have the availability group name, desired SQL version. That's going to be the build level that you want to get to. In our case, in our demo in just a second, we're using an environment with SQL Server 2022. And at the time of this video, CU20 was the latest. So we're going to be at a build level of 16.0 something. I will look at it in a second. But anyway, that you for this variable, you place in the build level that you want to be, and Ansible, this role will verify that. First, it's going to verify that that instance is not already at that build level, because if it is, then we're going to skip it. If it's not, then we're going to install the patch, and then at the end we're going to validate that it matches what we've defined here. The SQL instance name, you'll notice that we use default for the default instance name. That's not typical, but that's something that I had to use because we are using that SQL Server PowerShell module, and it uses a lot of paths. Basically, Microsoft designed that module to where it feels like you're just traversing a directory if you're on a Windows machine. So there's some specific things and details that you've got to use with that path. So if you're working with a default instance, you've got to put in use the word default for that instance versus just using. So if we had a default instance on a server named SQL1, you would just connect to SQL1. Well, the path needs to say SQL1/default to get to that instance. So there's some differences there in what you would typically see. So that's why you see default. SQL patch source. So that's the remote path, a UNC share of where that executable is. This role is going to take that executable from that share and copy it to those machines, those managed nodes, and then start the installation from there. So it's not trying to install over the network. The SQL patch file name, so that's the file name that we're going to be using. The patch checksum, so we're going to define the checksum in a variable, and then one of the first steps that Ansible is going to do is verify that exe checksum matches what we have defined here, so that we know that is the file that we want to use and nothing malicious or nobody's accidentally renamed another file to be that executable. And then the PowerShell modules path. So if SQL Server's PowerShell module is not already installed on our managed node, we're going to install it, and then at the end we're going to remove it. But if it is already installed on the managed node, then at the end we won't remove it. We'll leave it in the same state that it was in when we started. And right now this is it needs to be the SQL Server PowerShell module directory needs to be located on your Ansible control node. If you're not familiar with what a control node is, it's all in that guide that I mentioned earlier. But it needs to be there. It could be out on a file share too and just get copied to that managed node and then installed. But you'll see in a second this whole process. Optional variables, patch primary. So you can set that to true, and it's going to go ahead and patch the primary as part of this process. If it's set to false, it's going to patch all of your secondaries and finish. If that's the case, you could wait a week or 2 weeks, whatever your typical wait period is, and then come back and run this same playbook again, and then it's going to see that your secondaries have already been patched, and then it's going to go ahead and figure out, okay, I can go ahead and fail over from that primary, patch it, and then fail back as long as SQL AG failback is set to true, which is the default. Some other things here as far as the patch arguments, the SQL port, a reboot timeout, and then we've got the workflow. That workflow pretty much follows what we just looked at in the manual SQL Server AG patching checklist. So we got prerequisites where it's going to copy the executable SQL Server PowerShell module if needed. It's going to, step 2 is going to identify the primary. So we're going to see which one's the primary because we're going to patch it last, if at all. And then step 3, patch secondaries. We're going to go through all those steps of setting that failover mode to manual, installs the SQL patch, reboots the server, verifies the new SQL version, and then resets that failover mode back to automatic. And then that step actually happens if we set it back to automatic even if patching fails. Step 4, we're going to fail over. We're going to fail over that primary to one of the secondaries. But first, before we do that, we're going to validate that that AG is in a healthy state and it's synchronized, and that secondary is at the build level that matches our desired build level that we defined in our variables. And then we're going to patch that primary. Step 6, we're going to fail back if needed, and then we're going to clean up. We're going to uninstall that SQL Server module if the role installed it. If we didn't install it and it was already there, then nothing's going to happen with that. And we're going to delete that exe file. Here is just an example playbook. Gather facts true. These are some vars. In the demo, I'm going to show you can set variables here directly in the playbook, but I've actually got a SQL Server group defined in my inventory file. And then I also have a group vars file named SQL Server.yaml to where I have all of the variables defined in. So let's go ahead and just switch over to the environment we're going to be working in, and let's make sure everything was reset. All right, so this is the dashboard. Right now, I believe so SQL 4 Insta, which is one of the named instances, it is currently the primary replica. So let's go ahead and just look at the dashboard for it. So we can, and I have this, I have Management Studio. This is SSMS 21. I have the dashboard set to refresh every 2 seconds so that we can kind of see when failovers occur, whenever this failover mode is changed. So it's refreshing in the background every 2 seconds. We can see right now the primary instance is SQL 4 Insta, and everything is set to the automatic failover mode. Everything's green. So from the dashboard perspective, everything looks like it should be. And let's look at over here on the left, I have my inventory file, so host.ini. You can see that I have my group defined SQL servers, SQL 1, 2, 3, and 4. Instance name is default. And again, that goes back to how that PowerShell SQL Server module is using paths. So it's all set to default for those first 3, and then I have a named instance on that 4th replica. These are just my connections, my connection variables. So we're going to use winrm for this case, and then the port is 5986. We're going to use Kerberos. And then our AG name is Sandbox AG. Now, you'll see in my SQL servers.yaml file, this is where I have all of those other variables defined. You can see I have AG name here as well. So one of the things that PDF, one of those PDFs will show you is, in this case, which takes precedence. So if I had Sandbox AG 1 and then Sandbox AG just Sandbox AG over in host.ini, which one of those values would Ansible use? And let me know in the comments if you know which one. PowerShell modules path, so that's where the modules are currently. So I've just got it playbook_dir. That's a special variable that Ansible can use to see, okay, I know to look in the same directory that I'm currently in while I'm running that playbook, or it's in the same directory as the playbook that we're going to run. SQL patch source, you can see that it's out on share, and then this is the file name, this is the checksum, and then SQL patch arguments. So we're just passing in these command line arguments, the instance name, because if this machine had multiple instances, we're only focused on the ones that are defined here, that are replicas in our AG. AG name, SQL AG failback. So we're going to go ahead and fail back to that original primary. Remove the SQL Server module if we installed it. Patch primary is true. Reboot secondary is true. Reboot timeout temp folder. So this folder will be created on all of our managed nodes, and then that patch and that SQL Server module will be copied over and installed. And then here is our desired SQL version. So this matches our exe 16.0.4205, and I believe that's CU20. And then here's the playbook we're going to run. So patch SQL Server Availability Group, that's just our name. The host, we're going to use SQL Servers. That's our group defined inside of our inventory. We're going to go ahead and gather facts so that Ansible knows the most recent information about our managed nodes. If we hit any kind of error, we're going to say that it's fatal, and it's going to go ahead and end. And then here's where you could set serial to 1 if you wanted to patch each secondary individually. And then debugger, you can turn a debugger on in Ansible. And the only task we've got defined in this playbook is we're going to import our role. It's found in the Automate SQL namespace inside the MS SQL collection, and it's the SQL AG patch role. So let's go ahead and run it. So we run this playbook using Ansible-playbook. The playbook name, we're going to pass it the user. Now there's different ways that you could run this playbook if you were doing it automated, like not this specific playbook, but if you had something that you wanted to run on a schedule, then of course you wouldn't be passing in a username and password. You'd get that somewhere else, typically from an Ansible vault. But here, this is a use case that you'd probably use it to do this and watch it run. So I'm going to pass in my domain credentials, luke@sandbox.local, and then I'm going to be prompted for the password. Even though that says SSH password, in this case it's not SSH, but you could use SSH. And I've got some stuff coming out on Windows Server 2025 since OpenSSH is installed by default there. So it makes some of your setup a little bit easier. All right, you can see the first step is gathering facts. I'm going to go ahead and make this a little wider so we can see anything going on. The first thing you'll see when it starts is this failover mode changed to manual for all of our secondaries. And I'll kind of talk through each one of these steps as it's progressing. Again, all this code is out on GitHub if you wanted to take a deeper dive and look in. And so the first step, it's going to verify the checksum matches what we've defined. So it's going to actually go and check that exe, generate a checksum, and then match that checksum up with our variable that we have defined. So we can see everything look good there. Let's see, initialize fact for module installation tracking. So we're going to use a fact. If you're unfamiliar with what facts are in Ansible, head over to my blog at automateSQL.com, and I think I've got a post that goes over what are facts and kind of how Ansible uses those. And of course, you can always head out to Ansible's community documentation and look at those as well. So we're going to check to see if that SQL Server module is installed already. It's not installed on these machines. So we're going to install it, and then at the end we'll remove it, creating the temporary directory. And then we're going to copy that SQL Server module to a temporary location on the target inside that ctemp folder. And if we go over to, let's jump over to SQL 1 real quick, and I'll just show you that folder. So we can see we created a folder named modules. SQL Server, this is our SQL Server module, and it's going to, Ansible is actually going to install that, and then in a second you'll see that exe over here as well as for our patch. And the way Ansible installs that module is using, I will show you that. It's in this prerequisites task, and it is this task here. It's going to use the community. So there again, that's the community namespace. Windows is the collection, and it's going to use the win_ps module to install the SQL Server PowerShell module. And then it's going to register the result here. So let me switch back. So Ansible is fast. It's already going through a lot of steps, a lot faster than what I could do this manually. I'm just scrolling up to find that. All right, so right here is where it was. And install SQL Server module from the temporary location. Set the fact that we installed the module. So if we did install it, we're registering a fact so that we can refer back to that at the end. We're going to set the SQL Server or server instance variable conditionally. That's some internals that the role is doing. Get current SQL Server version. So we're going to make sure that these SQL servers are at the same major version. So that's going to be 16 for 2022, 15 for 2019. So if for some reason we had the wrong servers defined in our host inventory, maybe these were SQL Server 2019, and we were trying to install a SQL Server 2022 patch, instead of going through everything and then that executable failing, we're checking the major build version to make sure that 16 matches 16, which is 2022, and then it's going to check the minor version, which is the patch level. So it's going through several different checks before it gets ready to install. Here we're going to compare the current and desired SQL version. So it's also going to make sure that the build version of the server is lower than what we're trying to apply, because if it's higher and we're trying to install an old patch, we don't want to do that. Real quick, we can see that everything is, all the secondaries have went into manual failover except for the primary. It's left alone, and the patch is being installed. You can see everything that says not synchronizing. So here's our version checks. We're asserting that SQL Server version is valid for patching. Initialize a fact for the new primary. So Ansible went out and determined which of these replicas is the primary. So it put that into a fact so that we can refer to it later. And then identifies the primary. So debug. So if I was running this with a couple of other flags, this playbook with a couple of other flags like -VV, so that's a different debugging level that would turn on a couple of other things inside the role that's basically returned back to the end user. But we're skipping those, and that's why you see skipping. Validate AG state prior to installing the updates. So We're going to make sure that the AG is in a healthy state before we do anything. So that pre-check came back as okay, sandbox AG is healthy. We're not going to get AG state after patching. So we're skipped SQL 4 because that's our current primary. There's nothing to do on it yet. So that's why you see all of these steps skipped for that one. And then set secondary replica failover mode to manual. It's already did that. And you can see that it changed. If Ansible doesn't change anything, then you'll see just an OK message. If it does change anything, then you can see it says changed. And of course, if it fails, you'll see a bunch of red here. Check for pending reboot before applying patches. And then, so there's no pending reboot. That's why you see OK. And then fail if a reboot is pending before patching. So instead of having this role go ahead and reboot these machines, I'm having the role just fail. Let me know down in the comments if that's something that, what are your thoughts on that? I've went back and forth and just having it to go ahead and restart the machines, which is probably where I'll end up in another version after I do a few more updates to the role. But just to play it safe, I just left it as fail if it sees that, because there may be a step or two that's needed. Let's say a software installation occurred on these machines, and there's a couple other steps that's needed to complete that installation. Then I'm just going to exit out, and the DBA or the Windows admin probably needs to go and look to see why it's pending. If everything is good there, then we're going to proceed to install the updates on the secondary, and you can see over here we just failed over. So SQL 1 is our new primary instance. Everything was, we'll cover that in a second. Ansible is going faster than I can reading these steps off. So we're going to reboot, and that's already happened for SQL 1, 2, and 3. And then Ansible is actually going to, this is something that's really cool about Ansible, is it will actually wait for that machine to come back up and make sure that it's back online and accessible by just using one task. And that is a built-in module for Ansible. It's Ansible.windows. I think it's Ansible.windows.win-reboot or something like that. It's one of the tasks here defined. But I've always thought that was pretty cool, where if you're dealing with PowerShell, you'd have to kind of build something in to do that, a couple of other steps and code. You could certainly do it with PowerShell, but with Ansible, it's just built into a module. So once those instances are available, then we're going to get the new SQL Server version after the patch. So we're going to validate that new build matches our desired build, and if it is, then we're going to go ahead and proceed with a couple more checks. This all happens before we initiate a failover. So this is where we get our new build version. Each one of these have been updated to CU20, and now we're going to restore our failover mode to automatic. So you can see that it switched it back from manual to automatic, which SQL 4 is in manual because it was just being patched. Now I think it's trying to switch it. Fell over to new primary. So after all of those checks and validation has occurred, and then we failed over. Ansible found a secondary that meets the criteria of being synchronized, being healthy, and also as being patched. So once it found one of those that meets all three of those criteria, then it initiates that failover. Set the new primary fact from failover result. So we've got to set whichever primary is, or our new primary, we want to be sure to capture that value, because at the end we want to make sure that we fell over from that machine. And some of these connections can be done on the secondaries, but failovers and everything and some of the checks has to connect to the primary. So that's why we're keeping track of where the primary has been moved to. throughout this process. And Ansible's already finished over here. We can see that everything's been switched back to SQL 4, but I'll show you that dashboard in a second. Set secondary replica failover. I already said that. No, this is for the primary. Now it did those same steps that were applied to the secondaries. Now it's being applied to the old primary. So we set the failover mode to manual. And then we're going to check for pending reboot on that primary. Everything was good, no pending reboots. Then we're going to go ahead and start that installation. Restart the old primary, wait for SQL Server to come available, check the version to make sure it has been patched, and it has been to CU20. And then we're going to restore the secondary replica failover mode to automatic. So we're going to put that back from manual to automatic, just as we did with our original secondaries. And then we are going to fail back if necessary. And in this case, we did fail back. So you can see here that the fail AG back to the original primary. And that's some more debug information that you can turn on or off. And then at the end, we're going to get the AG state. We're going to do that by connecting to the primary. So that's why you'll see a lot of skipping. Here there's a retry. That failback can take some time, especially if it's a really busy AG or a really busy database where there's a lot of transactions that are occurring. Shouldn't be, because you're in a maintenance window. But just in case, it does take a couple of retries, and I think I've got 4. Yeah, I got 4 retries built in, so Ansible will wait a few seconds before it retries to connect while that fell back and fell over process is occurring. So it was able to connect, and then it's going to do the validation. Sandbox AG is healthy, and then we're going to go ahead and get the final SQL Server version on each one of the nodes. We're going to return that back to the DBA or whoever runs this role, and it's going to say that each one of these has been patched to the desired version. And then at the end, we're going to go ahead and delete the source files and uninstall that SQL Server PowerShell module if we installed it. And here's kind of a summary of all the changes and everything, the Ansible defaults. OK was 36. We made 11 changes. On the primary, we made 2 more changes. Can you guess what those changes were? And then a summary of how long it took. So we patched everything in about 12.5 minutes. So let's go ahead and go over here, and we're just going to check our versions real quick. You run a query, or I'm just going to quickly just refresh here. So there's another validation, and then we can see that everything is green. Failover mode is back to automatic. So that is a lot that we just went through. But if you have any questions or have any ideas of additional features to build into this role, let me know. You can go grab the role over at galaxy.ansible.com. Just search for the Automate SQL namespace, and then you'll see a MS SQL collection in there. I do have some other ideas around some additional collections for the Windows OS by itself, but there's a lot more roles that I want to build out for MS SQL space. And this is SQL Server on Windows. I think there's some other collections out there already for SQL Server on Linux, but not that I haven't seen a whole lot on Windows. There's a couple, but not a whole lot. So if you're completely new to Ansible, you can go and grab my guide, Ansible First Steps for SQL Server DBAs. Again, you'll find it out on the website. Just click this, send me the guide, and you're going to get 2 guides. And you'll also be notified whenever I'm posting any new blog post, and also any new videos. And of course, you can subscribe here on YouTube and hit that bell. Thanks a lot for watching, and I'll see you in the next one.